Hi, my name is Parker, and I'd like to introduce WildScribe, an app for recording various types of adventures and recreational pursuits. The app was designed with a skilled team of engineers, Jocelyn Wensloff, Derek Chavez, and Ian Lyell, with significant contributions from Elisa Barca and Renee Pinna. The idea for the app was born from a desire to document various types of interests all in one place. We've come to think of it as a bookshelf, with each journal on the shelf being home to information for a specific activity. Users can create new journals or pick an old one off the shelf and add logs. The choice to use Go and MongoDB for the backend was spurred by the want for an app that would be dynamic, scalable, and efficient. Since MongoDB doesn't require migrations, the backend is readily able to implement new activity fields. Derek and Ian will explain more about our architecture, but for now, Jocelyn will demonstrate the app and give an overview of the front end.
When a user returns to their app, they are taken to their home page, which consists of a collection of activity journals, as well as a breakdown of the amount of logs they have in each journal. A user can enter a journal and see a list of logs within that activity, as well as visually see the location for each log within that journal, and click on either the log or the marker on the map to see the associated log and location. For example, you can see that this user enjoyed a lovely bike ride off the coast of Antarctica in 1994. From here, a user can edit the information within, or even the type of log, delete a log entirely, or search for a log within the activity journal. Additionally, a user can see the statistics of their activity. By clicking the View Stats button, the user will see multiple graphs that are tracking the data a user enters, such as the date, their hydration and stress status, as well as the number of calories and hours of sleep prior to that activity. From here, a user can return to their homepage and create a new journal, enter into it, and get started with tracking their new activity. For the front-end tech stack, we originally implemented TypeScript, React, and React Router to allow us to create an intuitive user interface. After we implemented Redux to handle our global state management, we were able to expand and build on our existing app. The Redux store consists of two slices, one for user information such as the user ID and username, and another for user-associated adventures. We handle API calls using async thunks, dispatching actions to the backend, processing the data, and storing it in Redux, establishing a single source of truth for the app. Now the main app component primarily holds the routes available for the different components. When a user enters the app and they have logged in, they will be directed to the home page, which houses a collection of journals for each activity the user has logged. From there, the activity container component houses the new log component, the map component, the state page component, and the adventure card component.
I'm Derek Chavez, and I'll be speaking to the evolution of the architecture of the WildScribe project. We kicked off with a monolithic backend in Go, but as our app expanded through testing, we recognized the need for a more scalable architecture. We broke down our monolith into three distinct services: the user service, the adventure service, and the core WildScribe service. Each microservice is structured following MVC principles, ensuring a clear separation of concerns. The user service handles user management, the adventure service handles adventure data, and the WildScribe service ties it all together. To enhance deployment efficiency, we containerized each service using Docker. Now every service resides in its own container, ensuring consistency across environments and simplifying scaling. To ensure the harmony between services, we leverage gRPC, or Google Remote Procedure Calls. This communication protocol allows us to facilitate seamless interactions between our services, giving us language-agnostic framework for easier collaboration between the front end and back end.
Hi, my name is Ian Lyell, and I'll be showcasing some performance data that we use to validate the work we have done in our backend. For setup, our databases were seeded with 5,000 users and over 250,000 adventures, with them being spread in a logical fashion throughout the user base. We use Docker and Docker Compose to resource limits to control our app during testing. For testing itself, we utilize Python and the Locust library to create simulated users that can interact with our database in a logical way. As you can see from the data collected, moving from a traditional Rails PostgreSQL database to a Go MongoDB NoSQL database netted significant performance gains. But by breaking up our monolith into individual services, our app becomes more flexible and dynamic, enabling it to stay functional even when certain services, the user auth service in this case, experience heavy traffic, while also enable horizontal scaling when needed.
Throughout our time working on WildScribe, our team communicated frequently and worked cohesively. As we continue to develop the app, we'd like to implement drag and drop fields so that users can customize the fields in each journal, as well as tapping an external API to provide weather data for activities with the geolocation and timestamp. Another one of our goals is to make the app available on the App Store for a nominal fee to cover the cost of deployment, with any additional profit going to a charity that promotes environmental welfare. Thank you all so much for watching, and keep your eyes peeled for WildScribe as we head into the new year.